Yeah, right. I'm afraid my presentation is not as exciting and artistic as the previous one, but I'll do my best. Okay, I will tell you about Ookami, and this is what Ookami looks like. I think all of you know the Seawolf cluster, and that's the second cluster we have. First of all, the name Ookami might sound a bit strange. That's because it's a Japanese word. And we chose this name because it's an homage to the origin of the processor, which is Japan. And also because it's the Japanese word for wolf, and we are all sea wolves, so that makes sense. The cluster is not just available for us here at Stony Brook, but for researchers worldwide. And it's an NSF funded project. So who is actually the team behind Ookami? All these people here. We are doing this in a cooperation with the team at the University of Buffalo. So we have a team working there, and then the team here, like Robert, Ellen, Barbara, Tony, all the guys in the HPC admin group, and then the students there handling the ticketing system. I'm sure most of you interacted with them already. And also some graduate students. And the students currently working on the project are Smith and Catherine, who are doing a really excellent job there. And why are we so excited about Ookami and what's so special about it? The motivation for it was or is the huge success of the Fugaku supercomputing system in Japan at the Riken Supercomputing Center. And that's so, everybody knows it because it's the fastest machine worldwide, meaning it's #1 in the top 500 ranking. But not only that, it's #1 in all 5 major HPC benchmarks that are available. And that means that the system is well suited for a very wide range of applications. And it's also pretty power efficient doing that. So you can see Fugaku is enormous. It has nearly 160,000 nodes. Ookami obviously is much smaller. In Ookami, we have 176 nodes. Those are Fujitsu A64FX nodes. The same is in Fugaku, or nearly the same. It's a different series, but really minor differences in these chips. Ookami is the first open deployment of this technology outside of Japan, and it's an HPE Cray Apollo 80 system. Since Ookami is a test bed and users want to maybe test out different technologies, there are also some other nodes in there, like an AMD Rome node with 2 NVIDIA V100 GPUs, an Intel Skylake node, and 2 Thunder X2 nodes, which are actually the login nodes of the system. Summing all of this hardware up, Ookami delivers around 1.5 million node hours per year. And as I said, the key feature is really the Fujitsu A64FX chip. And here you can see how this looks like. It's an ARM-based chip with 3 key features. One is that it supports a high calculation performance, and on the other hand, has a low power consumption, which is obviously very important these days. It has support for SVE, scalable vector extension. In this case, we have a vector length of 512-bit. And the chip runs at 32 gigabytes of high bandwidth memory. So really very fast memory, not too big, but really very, very fast memory. The chip is divided into 4 core memory groups, CM3s, and each core memory group consists out of 12 cores. So altogether, the chip has 48 cores. What else is to say about Ookami? So if you come on the system, it probably feels like any other system, or like the Seawolf cluster. It has a standard Linux operating system, tool for authentication, standard file system, the Slurm workload manager for scheduling jobs. We have different compilers. That's actually very important because we see that the different compilers can deliver different performance for the different applications. So it makes sense to test them and see which compiler is the most suitable for your application. Like the GNU compiler can be very good for some applications, for some it's not good. It always depends on how well the compiler can vectorize the specific code. Other than that, there's the standard module environment with pre-installed software and libraries, which can be useful, and you're trying to keep that up to date all the time. Also some profilers and debuggers to help people actually working on the system. It's an NSF-funded project, and of course, we want users to make efficient use of that and to have their stuff running fast and get good performance. So we are trying to support them with a multi-modal approach that we are having, like a Slack channel within the IACS Slack. So you probably, all of you are in the IACS Slack, so you can have a look in the Ookami Slack channel there too. Then we have virtual office hours twice a week where people can just jump into the Zoom call, ask questions or get any feedback and then leave again or stay on and have a conversation. The ticketing system, the same as for Seawolf, and webinars about different tools that we think are beneficial for our users. For example, we will have one webinar in around 2 weeks about the Cray profiling tools. In case you're interested in that, just have a look at our website and maybe register for it if you want to. Where are we in terms of the project timeline? So the whole Ookami project started in 2019. Then the system was procured and then brought here to Stony Brook, and it's actually located at the Seawood Center. And then it was installed. We had early users on there, and since beginning of 2021, the system is open to researchers worldwide. So we actually have somebody sitting in Australia using the system here and all over the country and so on. And the next milestone we're going to have is in October of this year, Ookami will become an Exceed service provider. Exceed is this network of clusters within the US where everybody can get an account and do their calculations and simulations on a specific cluster they're interested in. So Ookami will be integrated into this network. So before that, so right now allocations are completely done through us here at Stony Brook. So people submit a very short project request, why they want to use Ookami, what do they want to do with it. And then they can get an account which is valid for 1 year and can be renewed after that if people are interested in using it further. And when Ookami will be an Exceed service provider, this of course will influence all the other people on there, but not too much. So everybody who has an account will still have their account that will stay active. The priority might be reduced. So when a lot of people come with an Exceed and do calculations, other shops might wait a little longer, but that's it. So what's the current status of the project? We have around 230 users, some of them more active, some of them less active. It always depends. In nearly 80 projects. And most of the projects running on the cluster are from universities within the US. So around 10% of all projects are from Europe, the rest is from the US, and like 7 to 8% from industrial, like from companies who want to test their code on it or do some other benchmarking, with the rest universities. Most people using it are external users, meaning not people from Stony Brook and also not people from the core team at Buffalo. So around 2/3 are external people from other parts of the world and from other institutions. We have a complete list of all the projects using the cluster on our webpage. And if you're interested, it's worth scrolling through or just reading the titles, because it's interesting what different disciplines make use of this cluster and are interested in using that. Yeah, for the sake of time, that's it. Our website, we have all the information there. If you're interested, have a look and maybe get an account yourself if you're interested in trying it out. Yeah, thank you.
Maybe you could comment on what applications would really benefit from Ookami, say compared to Seawolf.
Yeah, well, it depends a lot on the application, as you said, depending on how much memory it will use, depending on how well it can or can be vectorized, is already vectorized or can be vectorized. So those are the main points: vectorization and memory usage. I'd say.
And is it just simulation code?
Machine learning. Also machine learning. I mean, Smith is the expert in that. He's doing a lot of PyTorch work on Ookami and has some pretty good results there. You can comment on that if people are more interested in PyTorch and Ookami or any other libraries.
Do you have any front-end compilation between one of the Ookami node and the single GPU? Because like the next generation US supercomputer, they all have GPUs.
Right.
All of them we have GPUs, right? So,
Right, yeah.
But the Japanese one, the Gaku, it doesn't have any GPU because we know it's really hard to program on GPU comparably. So if we can have a good performance on CPU or on those kind of nodes, so it's really good.
Yeah.
So we have the
We don't have a performance, a comparison of single node performance against GPU. I don't think we have done that. One thing is important, of course, multi-node shops benefit much more than a single node shop. And some applications might not be very well suited for GPUs. If you have something which needs a lot of double precision calculations, maybe something like that might not well be suited. It always depends on the application.
Okay.